Ear damage from scuba diving. If the force on the tympanic membrane increases by about 1.5 newtons above the force from the atmospheric pressure, the membrane can be damaged. When you go scuba diving in the ocean, below what depth could damage to your eardrum can start to occur. The eardrum is typically 8.2 millimeters in diameter. In this numerical, what he is saying is, if the force on the tympanic membrane is more than 1.5 newtons, then the membrane will damage. And then the diameter of the membrane is 8.2 millimeters. Now we have to find out the pressure and then the depth. Okay. So here the force is given. So this is the maximum force, 1.5 newtons. Beyond this, the eardrum will damage. So this is the maximum force given to us. So force on the eardrum is 1.5 newtons. And then diameter is given to us. Diameter is 8.2 millimeters. Therefore, radius is equal to 8.2 by 2 is equal to 4.1 millimeters. Now we will convert the millimeters into meters. Therefore, 4.1 times 10 to the power of negative 3 meters. We know pressure is equal to force per area. And then here we have to calculate the area. Area is equal to pi r squared. So plugging in the values, we will get the area as 5.28 times 10 to the power of negative 5 square meters. Okay. Then pressure is equal to force per area. Force is 1.5 newtons. And then area is equal to 5.28 into 10 to the power of negative 5 square meters. Therefore, the pressure is equal to 28,403.6 Newton per square meter, or 2.8 into 10 to the power of 4 Pascal. I can write here 2.84 into 10 to the power of 1, 1, 2, 3, 4, no, 4 Pascal. Okay. Now we have to find out the depth. How to find out the depth? The formula we know, no? P is equal to rho GH. Just I will explain how we got this formula. Let us consider this be the a small tank, water tank. Okay. And then now we are trying to find out the pressure at the bottom of the tank. This is the bottom of the tank, bottom. And then the tank is full of water. Okay. This is full of water. Now this is the length and this is breadth and this is height. Okay, 3 dimension. Now we are trying to find out the pressure at the bottom. We know pressure is equal to force per area. Am I right? Then here, what is the force? Force is the weight of the fluid on the surface. Am I right? On the bottom surface. So here, force is equal to mg. Now, how to find out m? To find the m, we will use the formula density is equal to mass by volume. Okay. So from that, m is equal to rho v. V is the volume. Therefore, we can find out the volume of the water in the tank. Am I right? Because we know the dimensions of the tank, we can find out the volume of the water in the tank. Therefore, volume is equal to length into breadth into height. Length into breadth is equal to area, area into height. Okay, A is the area. Thus, we have the force is equal to V rho G. Am I right? Because mass we will write as the rho V. Am I right? I write like same way. Instead of mg, I will write rho v. Rho v g. Okay. And then instead of p, I will write F is equal to A, H, rho, G. This is the force. Now, pressure is equal to force per area. So, P is equal to A, H, rho, G divided by area A. So, A goes off. We are left with H, rho, G. Same. Here I wrote rho G H or H rho G. Both are one and same. Am I right? Rho is the density of the fluid, and then G is the gravity, and then H is the depth. So from this formula, we can find out the H. H is equal to P by rho G. And then plugging in the values, we get H is equal to 2.8 meters. So if the scuba diver is at a depth of 2.8 meters, nothing will happen to the tympanic membrane or the eardrum. Suppose if he goes below that level, then there is a possibility of damaging the eardrum. That's it. Hope this helps. Thank you. Bye bye.